Hey guys, we're back in chapter 5, even though we're in unit 2. So remember, unit 2, we're just looking at all these different ways to take derivatives, all these different formulas. So that's all. That's why chapter 5 is built in here. So today we're going to look at some inverse trig functions and differentiation with them. I have the domains, ranges, and graphs up here just to jog your memory about what they look like. Okay, the biggest thing that I need you to get from the above information is that if we're looking at inverse sine, we are going to look in these two quadrants. So think about this. Sine is your y. So if you're looking at these two quadrants right here, you'll see y is positive, y is negative. This is how I always thought through it. If you're looking at inverse cosine, we are going to be pulling from these two quadrants. Think about cosine. Cosine is x is positive, x is negative. And then if we go ahead and look at inverse tangent, we're looking at these two also. Tangent is sine over cosine, so y over x, and then we have a positive and negative. And of course, I'm speaking in regards to the unit circle. So you can see looking at this, like right here, inverse cosine goes from 0 to pi. And if you look up above here, do you see 0 to pi? And then go ahead and look at sine and tangent. And you can see if we're pulling from the unit circle, we're using sine and then tangent here. Okay, so we're going to use this as we go through the next problem. I also actually wanted you to recall about cosine, like cosine is x over r. So let's see if we can squeeze that at the top. So at the top, let's just review what all of this is. Remember cosine of theta? Cosine is your x-coordinate, so it's going to be x over r. The reason it is just your x-coordinate is because r is 1 when you look at the unit circle. So then secant is the flip of that, which is r over x. Okay, the next one will be sine. Remember, sine is your y value. That's y over r. And then associated with sine is cosecant, which is r over y. And then tangent. Remember, tangent is sine over cosine, so y over x. And then cotangent is x over y. Okay, so as we dive into this, let's remember this, how this is associated, and then also down here where we have inverse sine, cosine, and tangent defined. So what this first one is saying is what arc sine of 0 means. What this really is saying, sine of what angle is 0? So it's like a backwards question. Think about your unit circle. So I'm looking right here at inverse sine. When is sine 0? Sine is 0 here because that's when y is 0. Sine is also 0 here. But pi is not going to be my answer because pi is not in this region. So my answer is just 0. What this next one is really saying is cosine of what angle is negative root 3 over 2? Well, look at cosine. Cosine, what this is saying again, cosine of what angle is negative root 3 over 2? Where is negative root 3 over 2? It's right here and right here. We are not going to use this one because inverse cosine is right here. It's the notch right above this. Remember, this is like a big number. It's almost 1. So if I was thinking about this split, I'm right above pi. This is pi, and if I go up pi over 6, if you don't remember your unit circle, that's 5 pi over 6. Okay, on the next one, you're going to have to use your graphing calculator to get this answer. All you type on the graphing calculator, I'm not going to pull it up for this one, is shift tangent. So arctangent is the same as inverse tangent written like this. So on your graphing calculator, if you hit shift tangent and then type in negative 3, you'll get negative 1.249. Can you guys go ahead and try that and make sure you get the right answer? Make sure you're in radians. Okay, and then the next one, arc secant. Let's change that. We can look at arc cosine instead. So let's go ahead and rewrite this as arc cosine. Okay, but cosine and secants, they're going to be reciprocals. So this is going to be arc cosine of negative 1 over root 2. That doesn't look familiar based on the unit circle, but if you rationalize it, you're going to get negative root 2 over 2. So cosine, this is going to be like at a 45-degree angle. Think about where this is located. Okay, so we have 1 right here, but this is negative. So I need to go over here. This is, if you recall, 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Counts by odds. So I'm right here, and my answer is going to be 3 pi over 4. Okay, so that's just a review of some pre-calc stuff. Let's go on to the next one. What these are saying is evaluate the secant of the arctangent of negative 3/5 without using a calculator. So you probably did something like this last year where we're looking here. Now this stuff inside right here, remember you take secant of some kind of radian. Remember what arctangent means. This means tangent of what angle is going to give me negative 3/5. I have to find out what that angle is. So again, remember what this means. I'll write it above. This means tangent of what angle is negative 3/5. If we know what this angle is, then I can take secant of that angle. Okay, but we really don't care what it is because we can use triangle relationships. So what we're going to do is we're going to look here and say, where is arctangent defined? Look up here. Tangent is in these two quadrants. Because it's negative, we're going to be in this quadrant. Also, look at what is tangent. It's up here at the top. Tangent is y over x. So look what we have. We have y over x. Okay, so we are going to, in our picture, draw a triangle down here. The y is 3 and the x is 5. Remember, if you're looking at this, this is your x, this is your y, and this is your r. Now, this is going to be my angle. So this, I lost the picture. This is my theta right there. Let me write that in. That's my theta. So now what the question is saying, secant of this theta. Well, what is secant? Let's go back to the top. Secant, as I'm looking at this, is going to be r over x. Look at our picture. This is the radius, which I don't have. So I'm going to have to do some work off to the side to find that. I'm going to say x squared plus y squared equals r squared. So 9 plus 25 is 34. So r is going to be the square root of 34. So I can write that in now that I know it. This is the square root of 34. I'm writing it in green because we figured it out. So now I can find the secant. So now I can say the secant of arctangent of negative 3/5 is, remember we saw up above, it was r over x, so square root of 34 over x. So why this was kind of cool is we were able to find the secant of some angle, but we never knew what that angle was, and we really didn't care because we could use the picture. Okay, going on to the next one. Now this one, they just use all algebra. What I mean by that is there's no numbers like there were in the last one. So again, let's review what this means. What does arc cotangent mean? This means the cotangent of what angle is going to give me x. Well, x is really over the number 1. Look up above. What's cotangent? Cotangent is x over y. So in this case, sorry guys, we're doing a lot of back and forth. This is going to be x over y. Now it's confusing because there already is an x there. Okay, so because it's positive, we're going to be in quadrant 1. Now the fact that there's already an x there and this is x over y, this just means this is how much we travel, the x is how far we travel on the x axes, and then this is going to be the y. So I'm going to go over x and up 1. Okay, so if I go to write this, over x and up 1. Now I need cosine of this theta. Okay, so to get cosine of that theta, well, what is cosine? Cosine, if you look up above, is x over r. I already have my x right here. I need my r. So I'm going to go ahead and use Pythagorean theorem. So I'm going to get x squared plus 1 squared equals, we can call it r squared. I'm trying to find this piece right here. So r squared, r is just the square root of x squared plus 1. So in green, here's our new thing that we found, square root of x squared plus 1. Now they're asking for cosine. Remember we said cosine is x over r. So our final answer will be cosine of arc cotangent of x equals x, which is x, over r, which is square root of x squared plus 1. Okay, so a little refresher. I think we have one more. Okay, look at this one. How do we solve this equation for x? Well, if I want to get x by itself, what that means is I want this gone. So because arc cosine is the inverse cosine, we're going to undo it. So we are going to apply the cosine to both sides. So we're going to say cosine of arc cosine equals cosine of arc secant. Now the good news is on the left it's gone and all I have is an x. Now on the right, the cosine does not wipe out the arc secant, but can't we rewrite secant? Okay, if we draw this kind of like we did on the first one, so I'm looking at this, remember that x is really over the number 1. Okay, if you look back at your sheet, secant is r over x. So as I go to draw this, now it's positive, I'm right here. If secant is r over x, then this is my r and that's my x coordinate. So my radius has a x and my x coordinate has a 1. And this is theta. So now what I'm going to do is I'm going to take cosine of this theta right here. Well, what's cosine? Is it cosine x over r? So all I'm doing is flipping these. So now it's x over r, which is 1 over x. Cross multiply, you get x squared equals 1, and x is plus or minus 1. Okay, so that's a little background, just a quick about 10-minute refresher. Now we're going to go on to the calculus. It says day 2, but this is really day 1 and day 2 put together, because that really wasn't like a full day. It's just a new idea. Okay, you guys have to memorize these. I know it looks like a lot, but it's not going to be that bad. A couple ways to look at them is look at I have sine here, and then cosine over there. Do you see that has a co? Look at the difference. The only difference between these guys is that this is positive right here and this is negative. So I line them up for an easy way for you to study. So if you know the one on the left, if you put co in front of any of these words, you get the same thing on the right, but now it has a negative. Okay, so I recommend memorizing the left, and then the right side is just going to have a negative in front of it. The good news is this isn't difficult to apply. You know the formulas and you'll be good. So let's look at the first one and let's jump right in. So it's asking for the derivative. Oh, it doesn't say it. Let's find the derivative. Okay, so we're going to find the derivative. Okay, so f prime. This is chain rule. Remember, u is a function of x. We dealt with that when we did chain rule before. So I want you to find, do you see this u right here? That is going to be our function of x. So on the first one, what I'm going to ask you to do is to highlight that. Once I get my highlighter up. Okay, here is our u. So in this case, our u is a 2t. Now we don't have to write that out. I'm just reviewing chain rule with you. What it says to do arc secant, so do you guys see we're right here? It says put u in absolute values, square u minus 1 under the radical, and then whatever u is, put its derivative up top. So let's just go ahead and follow the directions. It says put u in the bottom, square u, so 4t squared minus 1. The derivative of u is 2. Okay, and the only other thing that we could do if you see this is we could cancel those 2's. So then now we're going to have f prime of x is 1 over absolute value of t, 4t squared minus 1. Did you guys catch a mistake? I wrote x and it should be t. Let's fix that. Hopefully you didn't do that. So f prime of t, 1 over absolute value of t, square root of that stuff. So here, these aren't bad. Just memorize them and we'll be good. Okay, here, do you guys see product rule? So we don't have chain rule because when you look at what we're taking arctangent of, it's just an x, but we do have product rule. So the first function is x, and the second function is arctan of x. So let's go through and take this derivative. So h prime of x, it's going to be first, which is x. Now we're on the derivative of arctan. Here's the derivative of arctan. It's 1 plus whatever follows arctan squared on the bottom. So our case is going to be 1 plus x squared. And then it says whatever you take after arctan, take its derivative up top. But look at our value here is just an x, and that derivative is a 1. Plus, and then you copy the second, which is arctan of x, and the derivative of x is just a 1, which we totally don't need to write. I just don't want you to forget about it. So h prime is now x over 1 plus x squared plus arctangent of x. So another good news, because we're going to think positive, is there's not a lot of algebra to do because our answers are so weird looking. Okay, memorize these 3 things and you're good for today. Okay, let's go on. So on the next one, this totally looks like what rules, guys? What would you use here? Do you see that it's chain rule? Okay, so chain rule because we're not just taking the cosine of a value, we're taking the cosine of arc sine. So that is going to be our inside stuff. So remember with chain rule, we start on the outside. So what's the derivative of cosine? It's negative sine. Copy the inside stuff. Now take the derivative of arc sine. Up above, the derivative of arc sine is right here. It's the square root of 1 minus whatever this is squared. So ours is going to be in the denominator, the square root of 1 minus x squared. Then it says, take whatever follows, where are we at? Take whatever follows the arc sine, and that derivative goes up top. So what's the derivative of x? Just a 1. Now, I don't know if you caught on to something, but remember arc sine is the inverse sine. It undoes sine. So right here, you have sine and arc sine. That wipes each other out, just like we did up above. So now you're left with negative x over the square root of 1 minus x squared. Okay, look at this, 16 minutes and we're almost done. On to D. Do you guys see product rule? You have a first and then you have a second. Natural log is here. Remember, we love natural log. That's nice and easy for us. So to find this derivative, it's going to be first, which is x. Now we're taking the derivative of arc cosine. It has a co, so it's going to be a negative, and it says cosine, so it's going to look just like sine, but with a negative in front of it. So let's go back up here if we need to, because we're just learning this, so let's review. Arc sine says whatever follows it, or I'm sorry, we're over here, arc cosine, but remember they're the same, except on the right it's negative. Whatever follows it goes on the bottom, and it's square root of 1 minus that squared. So let's go ahead and do that. So whatever follows it goes on the bottom, and it's a square root of 1 minus that squared. Because this is a 2x, we are going to square that and get a 4x squared. Because this is a 2x here, we are going to take its derivative and put it in the numerator because that's what they asked. Because it's arc cosine, we have to make it negative. Plus the second, which is arc cosine of 2x, and the derivative of the first term, which was x, is just a 1. Now going on, negative 1/4 is a scalar. Whatever follows the natural log goes on the bottom. So 1 plus 4x squared. The derivative goes up top, and the derivative of 4x squared is 8x. Finishing off our answer, we have negative 2x over the square root of 1 minus 4x squared plus arc cosine of 2x minus 2x over 1 plus 4x squared. If I lost you there, do you guys see this 4 cancels the 8, and that's how we got a 2. Okay, this is looking good so far. We haven't had to clean up any algebra. Our answers all look nice and neat, and on to the last one. Okay, kiddos, what rule are we using here? Do you recognize this as implicit and chain? So look at, we're not taking the arctangent of just an x, we're taking the arctangent of all of that. I also have multiple y's that cannot be combined. Good news is that's just a number, and that derivative will go away. Okay, arctangent, it's not a cotangent, so it's going to stay positive. If we, again, go up and look at the rules, arctangent, I'll just have you refer to it above. In the denominator, it says to write 1 plus u squared. U is whatever follows the arctangent. In this case, it's x plus y. So we're going to have 1 over x plus y squared. Then it says take u prime up top. So now we're taking this derivative. The derivative of x is 1, and the derivative of y is y prime. Equals, what's the derivative of y squared? Implicit, it's 2y, but remember there's really parentheses there, and what's the derivative of y? Y prime. Now after you do the first step of implicit, the next step is to isolate y prime. So let's go ahead and cross multiply. So we're going to have 1 plus y prime is going to be 2y y prime times the stuff in the denominator, which is 1 plus x plus y squared. Okay, now what I'm going to do is we are going to try to distribute this 2y prime to both things. The reason I'm doing that is I need to get y prime separated. So I'm going to have 1 plus y prime equals 2y prime plus 2y prime x plus y squared. I now want to put all y primes on one side. So I'm going to leave this y prime on the left, and I'm going to subtract 2y prime. I'm going to subtract a 2y prime x plus y squared. And then this negative 1 right here, or this 1, I'm going to subtract to get a negative 1 on the other side. Now that I have that, I can factor out a y prime from everything on the left, and I have 1 minus 2y x plus y squared equals negative 1. Now I'm going to take all of this and divide it to the other side, so I have y prime by itself. So now I'm going to have a negative 1 over 1 minus 2y x plus y squared. Okay, and at that point, we now have finished going through 5.6. Okay, if you guys have any questions, I will see you in class. One thing I do want to point out real quick is right here, I did not expand that. There was no y prime in there, so it didn't matter. Okay, hope you enjoyed this. Bye, guys.